This video is about Coulomb's law. We learned in the previous video that charges can be positive or negative. We can also measure the amount or magnitude of charge on an object or particle. The unit of charge is the Coulomb. Its letter symbol is capital C. Coulomb is defined as the charge transported by a current of 1 ampere in 1 second. If this definition at this point is not fully clear, don't worry, it will make more sense when we learn about electric current. For now, just remember that charge is measured in coulombs. Based on this definition, the fundamental SI unit combination of Coulomb is the ampere second, or AS. There is a very specific charge value that occurs in nature. It is called the elementary charge, and it is equal to 1.6 times 10 to the power of negative 19 coulombs. The magnitude of charge on an electron and on a proton is equal to the elementary charge. This means that the charge on one electron is negative 1.6 times 10 to the power of negative 19 coulombs, and the charge on a proton is positive 1.6 times 10 to the power of negative 19 coulombs. We learned in the previous video that opposite charges attract and like charges repel. In other words, charges exert a force on each other. Of course, the force exerted by the first charge on the second charge is the same as the force exerted by the second charge on the first charge. We can calculate this electric force between charges by using Coulomb's law. The law can be expressed by using this formula. Here are the variables that make up this formula. Since the force is inversely proportional to the square of the distance between the point charges, it is also called an inverse square law. In some cases, Coulomb's constant is expressed in a different form. Here is the formula for this constant, and here are the variables. Epsilon 0 is called the permittivity of free space, where free space is just another word for vacuum. In other words, the Coulomb's law formula, where K is equal to the Coulomb constant, so 8.99 times 10 to the power of 9 newtons meters squared per coulomb squared, should only be used when the charges are in vacuum. In other cases, for example when the charges are in water, epsilon 0 should be replaced by the permittivity of the given material in order to calculate K. Do not worry about this too much, because in IB physics, charges are practically always in vacuum. Finally, since electric force is a vector, it has a direction. When the two charges have opposite signs, the electric force is attractive, so the forces experienced by the charges point towards each other, and when the two charges have the same sign, the electric force is repulsive, which means that the forces experienced by the charges point away from each other. This completes our discussion of Coulomb's law. In the next video, we'll learn about electric fields.